All right, sorry for this. Okay, so today I'm not alone. I'm here with Samy, who accepted to join, and we are going to talk about Composer. Yeah, quick question to start. Who knows what Composer is? Okay, vast majority, I would say. Who operates Cloud Composer in production? Okay. So today we are going to talk about an incident that occurred on Cloud Composer, how we managed it and what we learned from it. And we will take this incident as an opportunity to highlight some limitations of Cloud Composer. And I hope this will be the start of a discussion and maybe a debate with the pizza just after. Quick word about us. I'm Benoît and he's Samy. We are both data engineers at Artefact. Artefact, I don't know if, yeah, maybe a quick poll. Who knows what Artefact is? Good, good, good. Okay, we are, for the rest of us, for the rest of you, we are a consulting firm and we are specialized in data. We are a team of around 35, 40 data engineers at the moment, and we work a lot on topics like Cloud Composer and so on. All right, let's start with a bit of context. The mission we had, this was a new mission that began early this year in January. The mission was to establish solid foundations on Airflow to scale to more use cases. A few figures about the environment. So we had around 200 DAGs. We were running the production in January on the Composer V1 and the version 1.17.1, which is deprecated, I know. And the Airflow version was the 2.1. About the organization, this was, I think, a bit similar to what you explained in the first presentation. It was a multi-tenancy cluster because we had 8 teams that were working on this environment and one environment for all those teams. And this represents around 40 developers. Okay, the incident. Maybe it's a bit too small, but I will explain the graphs. Mid-January, we started to see DAGs failing, and a lot of DAGs. As you can see here, here it's 10, so more than 10 DAGs failing at peak times, and also a lot of tasks in the queue, which is generally a bad sign. We can correlate this with this graph on the bottom left, which is the number of running tasks. Here you can see the number of running tasks is almost at 18 tasks, and 18 was the configuration of the parallelism, which is on Composer V1 is equivalent to the number of tasks we can run at the same time on the cluster. So we were basically at the maximum capacity of our cluster. We were on Composer V1, so we had a node pool with 3 machines, and we were at maximum capacity. The result of that, of course, is a business that is unhappy, and we had to manage the crisis. The first thing we tried was to mitigate the incident. The root cause, we had time to address this, but first we wanted to mitigate with a quick fix, maybe, and if possible. So the ideas we had was to first disable non-critical DAGs, reduce the frequency of execution, maybe if it's acceptable for the business, and better spread the load, because as we saw on the previous slide, we had peaks during the day of DAGs failing, and peaks also of tasks in the queue, and so we wanted to better spread the load to avoid DAG failures. This was on the paper a good ideas, but in the reality it didn't work because it was very, very hard to find the owners of the 200 plus DAGs. We didn't know who was behind. Some DAGs were, the developers were not there, so we didn't have the context about them, and no documentation. So this part, we worked on a couple of DAGs, but it was limited. The other option was to work on more technical aspects, I would say. For example, add timeouts for sensors to avoid things like that can retry for a very, very, very long time, and scan projects for anti-patterns to avoid unnecessary load. But the projects were quite good, and so again, this had limited impact. So with this, we reduced the failure rate from 25% to 20%, but still there were DAGs failing and people were still unhappy. So we had to work on the underlying infrastructure, and this is what we are going to present, because we chose to migrate from Composer v1 to Composer v2 because the Composer v1 version we had was deprecated. Okay, so this was for the post-mortem. Now, with this incident, we learned a lot along the way, and this is what we are going to share with you today. The best practices we chose to apply from the very beginning of the Cloud Composer v2 environment. And I give the floor to Samy.
Hi, everyone. So yeah, we had a migration to do in production, and we decided to add more work and add more practices to do. So these are the 9 subjects that we're going to tackle briefly today. The first one is might seem obvious, but use the same configuration for staging and production. So we had one environment, we had one composer environment per environment. So we have one for dev, one for staging, one for prod. And we decided to have the exact same one for staging and production. So what we mean by that is the exact same number of worker, same number of scheduler and everything, because we wanted to find issues before they arrive in production. Why is the configuration different in dev? Because we decided to have a more frequent listing of the DAGs in dev, so we have a quicker dev experience. And in staging and production, since it's punctual event, we reduce the scanning of all the folders. We also decided to have a local environment, so just a Docker compose, so that teams can easily try and apply the different things that we're going to see right after. So the second thing is, and we mentioned it, I think, in one of the talk before, was that Airflow uses connection to connect itself to other services. One issue we had with the previous environment is that everything was done through the UI, so people were copy-pasting the credential or relying on existing credential. And so when we deployed a new composer, well, we couldn't because all the connection were lost. So we decided to use a secret manager as a secret backend. So quickly, by default, when retrieving a connection, Airflow is going to search through all the environment variable to look for your connection. And if it doesn't, it's going to go through the database. And if it doesn't work, you have that error. And you can enable in the configuration a secret backend in which Airflow is going to look for first. So it's retro compatible with what you have. And this works for connection and variable and makes Airflow more stateless in a way because all the connections are stored outside of Airflow. And we're going to see right after that we can deploy connection more easily and programmatically. This is a snippet of the code that you can use if you want to use the secret manager of GCP as a secret backend. So how we decided to programmatically deploy all the connection and not go through the UI. So what happened is team So we can see on the right, they're going to create a secret in their own GCP project. For example, the credential they want to use in Airflow. And then they're going to change a configuration file, which is in a shared repository. The secret is not in the configuration file. It's a pointer to the secret in the project, just FYI. And so then they're going to create a merge request, because we're on GitLab, or a pull request. And then it's going to be reviewed by the core team to make sure they respect the naming convention, for example. If that works and it's approved, a CI/CD pipeline is going to then read the secrets in the GCP project, format it to a URI, which is the default format used by Airflow, and store it in the Composer secret manager with the correct prefix, as we saw right before. And now the connection is available in Composer environment and is not stored in the Airflow database, which is pretty useful if you want to do upgrades, which we're going to see. The third thing was to choose the right operator for the task. So we are going to see right after. We had 3 principles that we tried to apply. First, don't reinvent the wheel. Use primarily official operators, some from Airflow or official libraries. So for us, it was the GCP library for the operators. So we didn't mention it, but we're a team that was providing services for the data engineer. So if a team reinvents the wheel, make sure that the others don't. And so if you package an operation in an operator, make it available to all of the teams. You can do that in different ways on Airflow. And also make it easy for your teams to contribute to the library of your company so that they don't have to limit their so they don't have too much boilerplate. And last but not least, which is I think the most important one for us, no compute done by the Composer worker. So we had a principle, if there's compute that needs to be done on the cluster Composer, we use the Kubernetes pod operator. So quickly, we decided to package a base operator for the company. And so on the right side, you see the application code, which is the only thing that the data engineer team needs to provide. And then the rest is packaged to the base operator. So we have an init container that is going to get the secrets and inject it in the application code. So the team don't need to work on getting the credential and everything. They just need to provide the code. Fourth one, use IAM restriction. So we're going to see what we mean by that right now. So when you create a new Cloud Composer environment, it also creates a GCS bucket, which is where the configuration file, the DAG files are going to be stored, and everything is mounted to the Airflow component using GCS Fuse. And when you work with multiple teams that use the same environment, make sure to restrict where they can upload a file. So each team should have a dedicated namespace because, trust us, GSUT rsync to a D. I don't know if anyone is familiar with that, but that means that it's going to synchronize your folder with the folder on GCS and delete everything that is different. So during a migration, it happens that someone deletes all the DAGs of all the company multiple times in a week. So you can use IAM condition, and it's going to save your life because everything is stored on Git, but we were working on, I think, 150 projects, so 150 repositories. So what we mean by namespace, so there's 2 main folders, DAGs and data. With IAM condition, you can make sure that team1 can only write in DAG/team1 and on data/team1, and same thing for team2. And it really makes the migration and the life of the Composer very easily. Choose your port size wisely. So this is just a small reminder that everything, since it's running on Kubernetes POS operator, by default on GKE Autopilot, everything is going to have 2 GB of memory, which sometimes and most of the time is going to be overkill. So for example, we rely a lot on dbt, which uses 200 megabytes of memory. So if you don't use the correct pod size, you're going to have 1.8 gigabytes of memory priced for nothing. So just be careful on the size of your pod, which you run your code.
Okay, the list is almost all there. Do you follow all these practices or not? Maybe a few ones, not all of them. Okay. The one I'm going to talk about is policies. In the first meetup of the new season of the Airflow Paris meetup, Le Bon Coin did a very good talk about this, and we were listening, and so we had decided to implement this in our context also. So policies are basically just rules that are automatically checked by the scheduler and that will prevent DAGs that do not respect those rules to be deployed. Okay, and they are here to ensure good governance and to avoid the mess we had at the beginning, where we had a lot of DAGs without owners, without documentation, and so on. So the rules we applied were rules about ownership, metadata, naming convention, and email alerting. So ownership, we enforced the fact that a DAG should have a clear owner. And we have a configuration file to define the list of authorized owners. Metadata and naming convention. So basically, we enforced 3 DAGs that are mandatory. So the project, of course, the data domain, and the country. And with this, we can easily search the UI and so on. The naming convention, this is basically the same goal, but here the idea is to standardize the naming of DAGs. And email alerting, the issue we had was that we had a lot of emails, but with too many people in the loop, and so nobody took care of the emails. So we chose to restrict the authorized mailing list, and we enforced a few mailing lists. Okay, monitoring. What we learned from the incident also was that we poorly monitored the service, and the incident occurred, but we could have prevented it if we had proper monitoring. It's very difficult to monitor a Cloud Composer environment, and this is why I asked the question about who operates Cloud Composer in production, because it's a full-time job. So we came up with this, which is heavily inspired by the SRE principles. Here we have the 4 golden signals, so latency, traffic, error, and saturation. And we apply those 4 golden signals to metrics that are available in a Cloud Composer. For example, latency, you can monitor the landing time, so the time between the schedule and the actual execution time. Traffic, the number of tasks running. Error, the number of DAG parsing errors, very useful in a context where we have policies, cluster policies. Things like that, and saturation, the queue length, for example, it can be a good proxy of the saturation or a cluster that could be overloaded. The last 2 ones are about operations. Again, define maintenance windows. You can define this programmatically in a Cloud Composer. And this is very useful because in Cloud Composer, it's very hard to upgrade, for example, without downtime. So there is a strategy that is maybe the blue-green deployment that was showed earlier tonight. But this is very hard to do, and so we chose to define maintenance windows to install new packages or do upgrades. And the last one about snapshot strategies in order to restore the service in case of incident. All right, this was for the best practices. We wanted to highlight a few limitations about Cloud Composer. Even with those best practices, there are things we don't have solution at the moment. So if you have a solution, please tell us at the end. But at the moment, we don't have a clear solution for those limitations.
Yeah, so the first one is Composer V2 runs on Autopilot. So for those who don't know, Autopilot is a GKE distribution from GCP. And so the pricing is per pod. So you don't manage the nodes, you just send them the pods. And so the first thing is the pod resources on Autopilot, the limit and the request have to be the same. So if you ask for 500 megabytes, you're going to get 500 megabytes. If it exceeds, it dies. If you ask for 500 and say a limit of 1, you're going to pay for 1. So that is something that your pod cannot scale. Once you have memory in it, you stay with it. There's also a ratio that needs to be respected. So you have virtual CPU and memory that needs to be in a ratio between 1.1 and 1.6. And the underlying nodes can be slow to provide. So even if GCP abstract the nodes, you still need to wait for them to be provisioned. And so you have no control over them and how GCP handled them. The one in the middle, which causes the most issue, as you can tell, is there's very tight coupling between infrastructure and application. So we use Terraform to deploy everything on GCP, and that includes Composer. And Composer is at the limit between infrastructure and application, which means that if you deploy Composer with Terraform, you're going to handle the configuration or Airflow with Terraform, which can be very complicated. So for example, if you want to add a new package, it's going to reboot all the worker at the same time. It's not going to do a rolling update, so you're going to have a downtime if you want to adjust the package. So that's the third point. It's impossible to upgrade without a downtime. You want to add an environment variable. Every worker is going to be rebooted, even the web server. Also, currently the upgrade is not transparent, so you cannot upgrade one environment to another. It is in preview to be able to do that. But like we mentioned, when we provision a Composer environment, it creates a bucket. If you create a new Composer environment, it's going to create another bucket. So all of the teams need to change the bucket name to deploy their DAGs. So you cannot do that transparently, even if you have maintenance windows. The cost, so Composer is very expensive. It's around $2,000 per environment per month. So just mistakes on the slides.
A bit of French. Sorry for that. Also, about monitoring, Cloud Composer offers a limited set of metrics. Airflow offers a lot of metrics. There is a stats.d endpoint, and you have maybe 100 of metrics. Cloud Composer offers a set of those metrics, and sometimes it makes monitoring difficult. A few examples of that. All the timers are not available. So the metrics, you have the gauges, the counters, the timers, and the timers, they all are not available on Cloud Composer. So things like the schedule delay, that is the time between the schedule and the actual execution. You cannot monitor this with Cloud Composer. This is very bad. And also, if you go on the UI, you will see that there are a lot of inactive metrics, and so you have a limited set of metrics. The other thing is about cluster policies. I said that we enforced cluster policies. But there is no built-in support for cluster policies. So we hacked the behavior a bit to make it work. But as this is not built-in, this is very hard. For example, the propagation of the policies. If we want to make an update, we have to reboot all the workers. And so, as Samy said, there is a downtime for this. So if we just want to change a rule, we have a downtime. So this is painful.
Yeah, so we made huge progress thanks to this incident, just governance-wise and also performance-wise, because we have auto-scaling with Autopilot. And so we still have things that we want to do. So first, and this is a recurrent issue we have with Airflow, it's difficult for multi-tenancy. So for Airback, we want to restrict access to UI to show only your team's DAGs. And I'm going to point back to Le Benoît talk in January. They're very explicit, so it's very useful for us. Also, alerting. We hate to receive email saying a DAG fails. It's very painful. So we'd like to also support alerting with Teams and directly through ServiceNow, which is the ticketing. We also, and this is a very big point, is study to move to Gkey and actually manage Airflow ourselves. This will allow us to manage infrastructure and applications separately, so we can do rolling updates, but it also incurs a lot of charge to do that. And so we have multiple teams, 8 teams, multiple continents. And we want to make sure that everything is working pretty much the same for each DAG. So what we want to do is go to what we call pipeline as config. So for most of the time, it's retrieving a file in a bucket, loading in a BigQuery, and transform it. This can be abstracted and created by a config file. This would guarantee consistency and homogeneity everywhere. And it would also accelerate the creation of pipeline, because as of right now, people spend a few days every month or two to create new pipelines, which is a very slow process. So this is something we'd like to do next.
To conclude, the incident is now closed, so we are happy about this. If you are in a similar situation, be aware of the shortcomings we just mentioned before moving to Cloud Composer. And in short, what you may want to remember about this talk is that Cloud Composer is a managed version of Airflow, but still requires a lot of operations. And also a few features are not available. A few features from the open source version are not available on Cloud Composer. So if you are used to the open source version, you may be disappointed. If you enjoy this talk, do not hesitate to reach out, of course, and subscribe to the Artefact newsletter. I said this is the second best data newsletter. This is an alternative. We don't have the same content as you, Christophe. And yes, it was mainly an internal newsletter that we chose to open. And the next edition is tomorrow. So don't hesitate to subscribe.
Awesome, thank you. Okay, the pizza arrived, so I think we're gonna take only one question. But thank you for the talk. I think like all the points you made were really good. The list is really good. And also just a point before we go for the question. The talk gonna be on the YouTube channel. I will split all the talks in 3 videos, so you can go there, share to your coworkers all the talks. Is there any question in the room? One? No? You want to eat? Okay, there is one.
Thank you. Thank you for the presentation. You explained us everything, how you fixed the issue, but you didn't tell us, except if I missed it, what was the root cause of the issue? Why your first computer?
You're right. You're absolutely right. You didn't miss anything. We chose to not talk about this because it could take a long time. So the root cause basically was that we were on Composer v1. So the behavior on Composer v1, the infrastructure you deploy is a node pool. And the node pool we had was 3 machines. Okay, and these 3 machines were deployed in a subnetwork, and so there is a limited set of IPs you can use on this network. If we wanted to increase the size of the machines or increase the number of machines, we would have to have more IPs available. And this is where the problem was. We didn't have enough IPs to support new machines or machines with that were like M machines or things like that, and that could have more pods running in it. So basically, this was not enough IPs, and so we could not scale. We could not, the issue we had, well, we didn't have a downtime. We were in a degraded mode, 20% failure rate, but there were things running. So we chose to not redeploy everything or touch anything, to have the things that were critical that could still run. We played with the priorities and things like that to be sure that the things that were critical to the business could run. And so this is why we chose to not touch the underlying infrastructure. Does that answer the question? Okay.
If I can just add, also it was a 2 years old environment. just a 2 years old environment. So it was sufficient for the needs from 2 years ago. So that's why they decided to have a very strict number of IP. But then it worked so well that everyone jumped on it, and it was not supporting the load. And it happens mid-January because it was the end of the freeze during vacation. So there was a freeze between mid-December and mid-January. And so mid-January, everyone deployed the DAGs. The queue just became too long, and the timeout just happened.
Okay, thank you everyone, and I hope you enjoyed, and now we can go to drinks and pizzas, and see you in June, and thanks again Algolia and Memphis for the support. Thank you.